All right. Sounds like we'd like to go over either 13 or 14. All right, I need you guys to listen. Here's the plan for today. We'll go over a couple of these. Here's what I will say, okay? And this is kind of what sets sometimes an honors class away from, sets it apart from some other classes. We won't go over every single homework problem, but if I give you an approach to it, if I can say, oh, here's how you should set it up and solve it, you should be like, okay, I can take it from there, all right? That's kind of my encouragement and challenge to you, is I will go over some that are really tough, and if I say this one's similar to it and here's the approach on how to do it, your goal should be, yeah, I can try it. I'll take it from there. I'll try it on my own. I wrote down the answer. I wrote down the correct answer. I'll try it again tonight or in study hall, and I'll see if I can get it now. Does that make sense? That's kind of the your initiative part of it in the honors deal, all right, is that we can't go over every single one of them, but we'll give you an approach for a lot of them. Would you rather see 13 or 14? 13? Okay. So the thing you should do is make a plan. We call this a composite figure. What two shapes do you see here? I see a rectangle and a circle, or you could say rectangle, two semicircles, right? I mean, either way, doesn't matter. Now, are those the same? Are those two semicircles making up one whole circle? Or are they different sizes? Same size, right? They have the same diameter, they have the same radius, they're the same semicircle. So could we treat that as one circle? Yes. Okay. Now, we're not necessarily finding areas per se all the time. Okay. We're finding perimeter. Today's lesson, 11.2, will have to do with area. But today we're talking about perimeter. So can I find these lengths combined? Yeah, that's pretty easy. 13 and 13 make 26. Then I need to find the arc length of that portion and that portion. All right, did you recognize that 6 was going to the diameter? Okay, the 6 was right next to the center. It's halfway along that whole segment. If they wanted it to be the radius, they'd have to put it either up in this section, up above, or down here for it to be the radius, okay? So the radius of each of these semicircles is 3. How do I find the length of the red arcs? Let's call it arc AB. Arc AB is, what's the formula? Who could raise their hand and walk me through it? Paige, what's the formula?
Measure over 360.
Good.
Then either pi times diameter or 2 pi r.
Very good. Either 2 pi r, that's kind of the one we have written down in our notes, or pi times diameter. Now, the fill in the blanks are going to be the arc in degrees and the radius. So let's go ahead and fill those in. The arc that this is covering is 180. The radius is 3. Are you all with me? Well, it's calculator work from here. 180 over 360 is a half times 2 times pi times 3. If I write it in terms of pi, I put everything in my calculator except for the pi. Well, 1/2 times 2 is 1. Times 3 is 3. So this is either 3 pi in terms of pi, or it is 9.9. 9. What? 9.42? Or 9.42. Now, that is one of the arcs. 9.42. Isn't this one also 9.42? And did they write their answer as a decimal? I'm trying to remember. Yep. So, ready? To find the perimeter, I go 13 plus 9.42 plus 13 plus 9.42. Working your way around, or just double 13 and double 9.42 and add them together. So 9.42 times 2 plus 26, 44.84. 44.85, really close. Make sense? That's the approach for that one. Now, I won't have time to do 14, but I can walk you through the approach for that one. All right? If you were to trace, and if you're a visual person and you just don't know where to start, draw the picture and trace out the perimeter you're trying to calculate. Ready? I'm going to calculate that. Well, good news. That was 6. Then I need to find this arc length, and then 6, and then this arc length. That's my perimeter of this figure. Do you agree? Well, 6 and 6, and then this arc length. How do I find arc length? Well, it's a 90-degree arc. That's not the length. The arc length from B to C would be 90 over 360 times 2 pi times 3. And I'm going to double that because both of those circles are congruent. Once I find that arc length, I'm going to double it. Add 6, add 6. Done. Make sense? Awesome. Now, I was asked to finish up the problem we did in the notes yesterday. Again, I'm going to have to give an approach to this, and then I think you guys can take it from here. It's very similar to the one we just did. All right, so could you treat this as 2 separate problems? Ready? One, the red one, the red track, where 84.39. Now, I'm not going to be able to completely do this one because I don't want to rush through a new lesson today. All right, but I can show you how to do this. Wouldn't you do 84.39 plus 84.39 plus, not the circumference, what portion of the circle is that? What kind of arc is that? A quarter circle, semicircle? Semicircle, right? It's half of the circumference. So this portion right here, I'll call it the let's do the green portion there is going to be that arc length from E to F is 180 over 360 times 2 pi times 36.8, which is R. And then you would double it, right? And then you would add 84.39 and 84.39. Did you get that down, okay? Awesome. How about the blue one? The blue one has a different radius, doesn't it? Yes?
Yes.
So you'd still do 84.39 plus 84.39, but then your half circle arc is going to be a little different. You have to use the radius of 44.02 right here. The new radius in blue would be 44.02, and then you would double it. Does that make sense? All right. New notes for today. Areas of circles and sectors. The notes are there if you want one. Actually, they're not. Areas of circles and sectors. All right. Do we know the area of a circle formula? Pi r squared, right? Pi r squared. You said now we do?
Yeah.
Just a show of hands so I know how much to emphasize that. How many of you walked in today not knowing the area of a circle formula? Be honest with me. It's okay. All right. It's weird because as we change books and curriculum, like things change over the years. Like middle school, like what's covered and what's not covered changes. Pi times r squared. Pi times r squared. Let's do an example. Area of a circle with a radius of 2.5 centimeters. So area is pi times 2.5 squared. You're going to want a calculator. If we write our answer in terms of pi, I would do 2.5 squared, which is 6.25 pi. And what would the units be on that? Centimeters? Centimeters or square centimeters?
Squares.
Centimeters squared, right? Or square centimeters. If I want to write it as a decimal, I actually type in 6.25 times pi, and I get 19.63 centimeters squared. We're going to continue writing our answer in terms of pi and rounded to the nearest 100. Are the units confusing to you guys, square centimeters, or no? You good with that? I always get I don't have time for that. It's another conversation. Stay focused, Mr. Westfall. All right, diameter of a circle. We want to find the diameter with an area of 113.1. Well, area equals pi r squared. They told me the area is 113.1.
This announcement is for high schoolers grades 9 through 12. If you were planning to have a spring photo taken, please go to the main gym now or before 10 o'clock. At 10 o'clock, they start to close down. So if you are a high school student and are planning to have your spring photo taken, please go to the main gym within the next 40 minutes to have that done. Thank you.
Question for you. Do you agree we're trying to find the diameter, not the radius?
Yes.
Is squaring a number the same thing as multiplying it times 2? No, because the diameter is double the radius. But this r squared is not the same thing as 2r. Do you agree? So how are we going to solve this? Well, divide by pi and then take the square root. That'll give us the radius. Let's get that far. Ready? Divide by pi. Pi is a number. Divide by pi. 113.1.
It's like 36.
Ooh, yeah. 36.0008. Now, why am I writing it out like that? Well, if I were you, here's the habit I get into in my calculator. 113 divided by pi. I kind of forget that I have this calculator. So here we go. All right. 113.1 divided by pi is that number. Now, I want to keep it as accurate as possible. So I take the square root of the answer, and yours is the same way. Second negative we'll put in the previous answer if you put in a square root symbol first. So I'm taking the square root of that number, which is going to be really close to 6. So close, let's call it 6. All right? So we took the square root of both sides, and r is 6 centimeters. 6 centimeters. But they asked us for the diameter. 12 centimeters. So that's working backwards. If they give you the area, being able to work backwards to find the radius. And then if they ask you the diameter, you have to double it. Good on that? All right. Next, we're going to talk about sectors. So a sector of a circle is actually a part of the area. A sector is it's like a slice of pie or a slice of pizza. It's not a triangle. It's got a curved outer edge. All right, and it's always formed by 2 radii, plural for radius. Formed by 2 radii and then the intercepted arc. So that shaded area is called the sector. How do you find the whole area of a circle? Pi r squared. Remember yesterday how when we found listen, there's so many similarities from yesterday's lesson to today. Ready? Quick recap. Yesterday's lesson. How do I find the whole circumference, distance around a circle? 2 pi r, right, or pi d. So how do I find part of the way around the circle? 2 pi r times the measure over 360 that you went around, right? The fraction of the circle you went around. That's how you find part of the circumference, the arc length. Today, the whole area, if you're to paint it, right? Pi r squared. I'm not talking around, I'm talking inside. Whole area is pi r squared. So how do you find part of the area? Well, pi r squared times the part of the circle that's shaded, right? The fraction of the circle that's shaded. If it's a third of it, a third of the area. If it's half of it, half of the area. I mean, think about this in pizza all the time. They're always cut up into 8 pieces a lot of times. 8 pieces, 8 slices, right, Jackson? Right.
Sure.
And so if you say I'm going to eat 1 slice of pizza, what fraction of the circle did you just eat? 1/8. An eighth of the area. An eighth. 2 pieces? 2/8, or a fourth, right? A fourth of the area, and so forth. So that's where this formula comes from. The pi r squared is the whole thing. If you have any arc less than 360, like 180, you're eating half of that area, half of the pizza, right? Or what if the arc is 60 degrees? A sixth of the area. See where the formula comes from? So when it comes to like, oh, Mr. Russell, I'm terrible at memorizing formulas. Yeah, it's probably good to memorize this, but if you forget it, you could probably figure it out. Like if I'm finding this slice, I could find the whole area and then find out what fraction of the circle I'm shading. Do you agree? That's kind of the critical thinking portion of it. All right, now here's how this book is a little different than the old books. I'm going to make sure I emphasize this. I think I don't love the way they ask it, but it is pretty obvious once you find out what they're asking you to do. Find the areas of the sectors formed by angle UTV. Okay, so they shaded 2 parts. This is the part I don't love. But what angle is angle UTV? Oh, it's that reddish salmon. I guess that's a salmon, isn't it? Salmon color. It's that portion of the circle. All right. So that area is going to be, well, it's 70 over 360 times pi times 8 squared. If you use the wrong formula, man, it's gonna really hurt you. All right, I have students confuse the formulas. The arc length finds length. Sector finds area. Okay. Calculator time. This one's gonna be a little ugly, I think, if we type it in our calculator in terms of pi. Let's see. 70 over 360. I put parentheses around that. 70 over 360, and then times, I know 8 squared is 64, times 64. I get 12.4 repeating pi. Now, that's kind of a weird number. 12.4 repeating times pi. Let's see if there's a nice fraction for that. That's kind of ugly too. 112 ninths pi. Okay, that's in terms of pi. That's in terms of pi. Okay. Did you watch yesterday's video?
No.
Go watch. You'll catch on quickly. What units would that be? What units would that be? Inches squared or square inches, right? Now, that doesn't mean a whole lot to us. So what if we're asked to write it as a decimal? Well, we take that number times pi, and we get 39.095. So 39.1 square inches.
How do you make it into a fraction?
Make sense? Second PRB, I think. I don't use that calculator often. All right, go ahead and try this one on your own. Yes. Right. Right. So that calculator, for whatever reason, doesn't give you a decimal version. That might be a problem. You could do the number times 3.14.
That's what I have to do.
Yeah.
How do you do it? How you change it?
All right. So, quick application. There's actually a ton of applications. Like, what if you're pouring a stamped concrete patio out with a little, you see those with the fire pit in the center, stuff like that. And you want to find the area of this, or you're having different patterns in different portions of it. It's pretty expensive stuff. It's like $15 a square foot. So you want to be really close with your estimate on how much it's going to cost you. Application of how to find the area of that, and then portions of the area might be different styles or whatever. All right. Actually use this stuff. Back when I was a lot younger, my friend and I decided to build a raft and float down a river for 3 days. And like we made it out of those blue barrels, like the 55-gallon drums. You know what I'm talking about?
That sounds fun.
So we the mighty Tuscarawas River. And the math involved. So anyway, when you put the barrels like this, we don't care.
You know how people go off like what's that thing where you like what's the thing where they go down into the rocks like they're waterfalls? Oh, waterfalls. You know how people go off of barrels on those?
Oh yeah.
And they
I wasn't
die?
on a barrel.
No, but inside them.
Yeah.
People like die from that. Like,
Yeah, I did. No, I used the 4 barrels for flotation. We built a raft on top of it.
Who's your friend?
His name's Tim.
Okay.
Tim.
Are you guys still friends Couldn't you just taken like 4 pallets, screw them all together, and then put them on 4 barrels and just say you're good to go?
We had like 4 water protected compartments underneath. So like
That sounds very
it would have been more difficult to do that. We had a cooler in one compartment. We had
You have too much free time.
Right.
this was back in college. Like
How do you
tons
have
of
free
free
time in
time.
college?
It was in the summer. But anyway, quick math application. Do you guys know how much a gallon of water weighs?
No.
Isn't it like 5 pounds?
8.3 pounds. So an empty 55-gallon drum, 55 times 8.3 will hold, if it's fully filled with air, each one would hold 456 pounds of weight. So the raft was like 300 pounds plus our weight. You want to figure out how low in the water this thing will ride so that your compartments underneath the top will stay out of the water. So when you do that, you're actually finding the area of that whole sector and then taking away this triangular area.
How'd you get that in and out of the water?
Yeah, how'd you get it in and out of the water?
You can lift it, like the two of us. It's really heavy. All
I
right.
would have just left it in the water.
A center pivot irrigation system, you could just say a sprinkler, that rotates around a central pivot point to irrigate a circular region. You could just say garden. All right. Find the area of circle C. Now, do you notice the question? It didn't say find the area of that green region, did it? Because they gave us that. They want us to find, what if it was a whole circle? All right. Well, what's our formula? The sector. How many of you guys hear vector every time I say sector? Yeah. Vector.
Do the dance.
Oh yeah.
Mr. Westfall, do it.
That's okay. It's okay. I embarrass myself too much every single day.
No, it's funny.
Nobody can take a video of it. You know?
That's why I make you put your phones up there.
You should just do it just for the laugh.
Yeah, do it.
All right. So we've got, here's our formula for the sector. Agreed? Help me out. This is a critical thinking problem. What do we need to do? What's our process?
We need to find
48 over 3.
how much. We need to find the radius.
We need to find the radius. Very good. Yeah, we need to find the radius. Because if we can have the radius, we could do just pi r squared and find the whole circle. Right? Well, what do we fill in? What do we fill in for the sector area? 67,000. The measure of the angle that forms it is 48 degrees. All right, times pi r squared. Isn't 48 over 360 and pi, aren't those both numbers?
Yeah.
So we're going to divide them over. Okay, now it's kind of ugly. So just in all honesty, this is going to be a decimal answer. We're not going to write our answer in terms of pi. It's going to be ugly. All right, so here's what I'm going to do. I'll do it on the big calculator so you can see. I'm going to do 48 over 360 times pi to know what number I'm dividing from both sides. All right? Isn't that an ugly number?
Yes.
So without rounding it, watch what I'm going to do. And I recommend you guys do this in your calculators too. I'm taking 67,000. So don't type in anything. Like don't change that number that was just in there. Aren't I dividing that 0.418 number over?
Mm-hmm.
So I'm going to take 67,000 divided by, and I don't want to type in 0.42. I'm going to do second answer to get that whole decimal to keep it as accurate as possible. And that's a big number. What am I going to do with that number? That's equal to, that's equal to r squared, right? So we're going to have to square root. So I'm going to write this step here. 159950. 159950.
No, it's what?
All right. Hey guys, I need you listen. Everybody, be quiet. Hang tight. I need everybody to watch, and I'll answer questions here in a minute. Square root that answer, and I get 399.94. 399.94 what? Meters. that was just to find the radius of the circle. So this radius is 399.94 meters. So the area of the whole circle is pi times that 399.94 squared. Now, again, if you are strategic when you type things in your calculator, I'm not actually typing in 399.94. I'm taking that whole decimal, right? And what am I doing with that number? That's my... Guys, I wrote it out for you. It's right here. What am I doing with that number to get my answer? Squaring it and multiplying by pi. Okay. So answer squared times pi. And look at that. A beautiful, perfect whole number. Did you expect that?
Mm-mm.
Because we'd never rounded the whole time. In my calculator, I never rounded that whole time. 502,500. 502,500 meters squared. Okay.
When you have just done 360 divided by 48 and then get that times 57.
That's one way to do it. This is the I am a robot, I know nothing but to solve for R way. Do you guys hear what he's saying? Look up here. Look up here. Do you agree pi r squared is the whole circle? Oh, 1 second, Paige. I'll get you. Hey, guys. Do you see pi r squared is the whole circle? So how do I get that green part by itself? Caden's saying multiply by 360 over 48 on both sides. That's fine. Paige.
Every time I do 67,000, that's what I did wrong. Never mind.
You good?
Yeah.
All right.
I did wrong. It's 67.
A rectangular wall has an entrance cut into it. You want to paint the wall. What is the area of the region you need to paint? This actually happens a lot. I'm not just saying this because I'm a math teacher, but if you look on the back of the paint can, you'll see how many square feet it should cover. All right? And you have to find the area of your room. And there's always doors, there's always windows. There's not always arched windows. And I honestly, if I were doing this, I'd probably be like, I'll treat that as just a big rectangle and I'll have a little extra paint. Just to be honest. All right. But this is a math problem. It's challenging. So let's find the area of that teal seafoam wall. Go for it. You got this. It's telling you the diameter of that is 16. There's a couple ways to solve this.
Divided by 2. Just for later. Who's it trying to do? Or so you guys are like for that.
You tell me.
16 or 16.
I just came here today. I don't know.
And then obviously 16 is great.
Yeah, probably.
16 is
This is a new lesson. You're learning it for the first time with everyone else.
Oh, never mind, but no, 10.
I think probably
10 right there.
All right, let's pause for a second. Can anyone give us a plan to get the answer? Not an answer, just a plan. Jack.
I would do like find the area of the whole thing, and then get like the inside area of like the one like square you see under the half circle or the semicircle, and then find the area of the semicircle.
And then take away that.
Yeah, then take away that.
So this is a very non-mathematical way to write your plan. And I do this all the time. All right. If I find the whole area of the wall, this keeps me on track. I find the whole area of the wall. Well, that's not bad. That's just a rectangle. Subtract. I think Jackson's talking about this rectangle right here.
Yeah.
Subtract that, and then subtract the semicircle. Do you agree? That's a good plan. Does anyone have a different plan? That's probably the most straightforward plan I would do. Quick little checkpoint. What's the radius of that circle?
8.
Good.
Okay. Is that 16?
Okay, here's the answer. It's that. Okay, I'll just take the third one. I did that, okay. The first thing you do, 16 times 16, you get this. 16 times 16 is right here. That's this here. This, right here, 16 divided by 2 is radius. You can put 8 of this, 64, 64 pi. And then obviously you can, not that, you can, whatever I got somewhere out. You get this here times. This is the area of the semicircle, yes. Because that was my original thing before I made a mistake between 10. So but then you add that 56 to get that.
Did you get 579.47 square feet?
Yeah.
Quit.
I got 100.
Quit. Listen, I'm trying to explain it to you, but okay.
Oh, that's because you.
All right, let's break it down. For the wall, for the whole wall. Hey guys, quiet. Did you get 36 times 26?
Yeah.
That should be 936. Bless you. 936. For the rectangle, I called it the door rectangle. It was this one in green. What's the length? Or sorry, what's the width of that rectangle? What's the height? So 16 times 16 is 256. Did you get that? Then we have to do this semicircle. Now, could you call that a sector? Isn't that a sector of a circle? The area, right? It's 180 over 360 times pi times, what's the radius? 8 squared. All right, did anybody do 16? I'm wondering if you did 16 squared on accident for that. If you got it wrong. No? All right, type that in your calculator. We're going to have a decimal. 1/2 times pi times 8 squared is 32 pi, which I just typed it in all at once, and I got 579.47. If you got it wrong, did you see what you missed?
Wait, how did you type it in?
Which part?
Like
The up top right, or this whole thing right here?
the top.
Yeah, I did 180 over 360 times 8 squared, and that 32 pi. Questions on those? All right. 2 through 6 even, 7 through 10. 13, 16. All right. For 7 through 10, it's going to say find the area of sector, and it'll name it by its angle. There's going to be a couple shaded sectors. Find the smaller ones, the ones named by the angle. Okay? Can you guys read that? Tuesday's homework. Can you guys read that in the back? Can you read it in the back?
Yeah.
Okay. Olivia, did you bring in a pass? Sure.
I wasn't even getting it. It's not like can I have the paper printed? Why?